Their engines were still warm from the ferry flight, their formation barely 3 minutes off the ground, when the flak began bursting in perfect murderous rhythm around them, not scattered, not searching, but locked on, as if the gunners below had known exactly where they would be before the pilots themselves had finished climbing through 1,000 feet. And in that instant, somewhere over the hedgerows of Normandy or the flat fields of Belgium, in the autumn of 1944, a generation of German fighter pilots who had built their entire craft on stealth, on the element of surprise, on slipping in low and fast beneath the enemy's guard, understood, with a cold and sudden certainty, that the sky itself had turned against them, that an invisible eye had been watching their airfield since before their wheels left the runway, and that the war they thought they knew had quietly, irreversibly changed. This is the story of that eye, a squat, boxy radar set mounted on a trailer, homely enough to look almost agricultural next to the sleek machines it hunted, yet so precise, so relentless that it stripped the Luftwaffe of the one advantage it had clung to since the collapse of German air superiority, the ability to strike Allied airfields before anyone knew they were coming. To understand why this machine terrified veteran fighter pilots more than any interceptor they faced, you have to go back to the years when German airmen still ruled the skies with tactics built entirely around deception and timing. Since the earliest days of the war, the Luftwaffe's fighter bomber squadrons had relied on a simple, brutally effective formula for attacking enemy air bases: come in low, beneath the coverage of ground radar, use terrain to mask your approach, strike hard and fast while parked aircraft and ground crews were caught in the open, and be gone again before anti-aircraft guns could properly range in or defending fighters could scramble. This was the philosophy behind operations across the Mediterranean, over the Eastern Front, and later over the fields of France and the Low Countries, and it worked because Allied ground radar in the early war years, systems like the American SCR-268 and comparable British sets, were simply too slow, too imprecise, and too dependent on manual tracking to give defenders more than a few chaotic minutes of warning, often too late to matter. German pilots who flew those early raids remembered the exhilaration of it, the sense that they were ghosts moving through gaps in a net that could never quite close fast enough. But by the middle of 1944, that net had been rebuilt from scratch, and the men who rebuilt it were not soldiers but scientists, working out of a converted building on the campus of the Massachusetts Institute of Technology in a laboratory that would quietly become one of the most consequential engineering operations of the entire war. The MIT Radiation Laboratory, established in 1940 under the direction of physicists recruited from across the United States and Britain, had been given a single overriding mission: take the raw promise of the British cavity magnetron, a device capable of generating microwave radiation at wavelengths far shorter than anything used in radar before, and turn it into a weapon that could see farther, track faster, and aim more precisely than anything the Axis powers possessed. Out of that laboratory came a machine designated the SCR-584, a mobile 10-centimeter wavelength radar unit mounted on a trailer, compact enough to be towed behind a truck and set up in a field within hours, yet capable of a feat that had eluded radar engineers on both sides of the war: fully automatic target tracking. Earlier radar sets required an operator to manually adjust the antenna, chasing a blip across a screen, always a half step behind a maneuvering aircraft, introducing human error and human delay into every calculation. The SCR-584 solved this with a technique called conical scan. in which the radar beam itself swept in a tight circular pattern around the target, and any deviation in the returned signal strength was automatically fed back into a servo mechanism that adjusted the antenna to keep the beam centered on the aircraft, all without a human hand touching the controls. Once locked on, the SCR-584 did not lose its target through evasive maneuvers, through darkness, through fog, through the low cloud ceilings that had always given attacking aircraft cover. It simply held on, feeding a continuous, accurate stream of range, bearing, and altitude data to whatever it was connected to, whether that was an anti-aircraft gun battery, a searchlight, or a fighter control center coordinating an interception. When paired with the M9 electrical gun director, another marvel of American wartime engineering built around an analog computer that calculated a firing solution in real time, the SCR-584 turned Allied anti-aircraft batteries from a nuisance that German pilots had learned to fly through into a genuinely lethal, almost surgical threat, one that no longer needed to guess where an aircraft would be in the seconds it took a shell to arrive, because the computer already knew. But the deeper transformation, the one that truly haunted German fighter pilots, went beyond gunnery accuracy. It was about early warning, about the collapse of the assumption that an airfield could ever again be caught unaware. As Allied forces pushed across France in the summer and autumn of 1944, they brought this radar network forward with them, establishing chains of SCR-584 stations and associated ground-controlled interception centers that could detect a formation of aircraft climbing out of a German airfield, track its course and speed, and relay that information to fighter squadrons and flak batteries within moments, often while the German aircraft were still gaining altitude over their own territory. This meant that low-level, high-speed dashes toward Allied air bases, the exact tactic that had once given German pilots their edge, now flew directly into a defensive system that had already plotted their likely course before they crossed the front lines. Fighter controllers working from radar screens and mobile command posts could vector Allied interceptors to precise intercept points, timing their climb and approach to arrive exactly where the German formation would be, not where it had been minutes earlier. German pilots accustomed to slipping through gaps in coverage now found there were no gaps left to slip through. The radar picket lines had been layered and overlapped specifically to eliminate the low-altitude blind spots that earlier systems had suffered from, and the SCR-584's ability to track targets down to very low altitudes closed off the one avenue of approach that had always been the safest. Veteran pilots who had flown ground attack and airfield suppression missions since the early war years began noticing the pattern well before they understood its cause. Flak that used to walk blindly across the sky in barrage patterns, hoping to catch something, now burst in tight, accurate clusters directly in a formation's path from the very first salvo. Defending fighters that used to scramble late and chase from behind now appeared already at altitude, already positioned, sometimes seemingly waiting, and airfields that should have been caught completely by surprise showed signs of alert crews, dispersed aircraft, and manned guns minutes before an attack even began. For men whose entire tactical doctrine depended on stealth, this was more disorienting than any single loss in combat, because it meant the enemy no longer needed to see them to know they were coming. The psychological weight of this shift became undeniable during the last great gasp of German air power in the West, an operation launched in the freezing dawn of January 1st, 1945, when the Luftwaffe threw nearly the entirety of its remaining fighter force into a massed, low-level surprise attack on Allied airfields across Belgium, the Netherlands, and France, an operation later known as Bodenplatte. The plan depended entirely on secrecy, and surprise on hundreds of aircraft crossing the front lines at treetop height under strict radio silence, timed to catch Allied squadrons still grounded on New Year's morning after a night of celebration. In places where German pilots achieved genuine tactical surprise, the results were devastating, with rows of parked Allied aircraft destroyed on the ground before crews could react, and for a few hours it seemed as though the old tactics of stealth and speed still had teeth. But even on this operation, planned with such extraordinary secrecy, elements of the Allied radar and warning network picked up incoming formations far enough in advance to scramble defending fighters at several fields, and Allied anti-aircraft units directed by radar-fed gun-laying systems inflicted brutal losses on low-flying German aircraft that had nowhere to hide from tracking that no longer required visual contact to be lethal. Compounding the disaster, German flak units, uninformed about the scale of the operation and unable to distinguish friend from foe amid so many aircraft in the sky, shot down a significant number of their own returning fighters. But it was the Allied radar-directed defenses that delivered some of the operation's harshest lessons, confirming what many veteran pilots had already begun to suspect in the preceding months, that the Luftwaffe had lost not just numerical and material superiority, but the very tactical currency of surprise that had once been its most reliable weapon. The scale of losses suffered by the Luftwaffe during and immediately after this operation, hundreds of aircraft destroyed, and more critically, irreplaceable veteran pilots killed or captured, accelerated a collapse in the quality of German fighter aviation from which it never recovered, because an air force can rebuild airframes far more easily than it can rebuild the experience, judgment, and instinct carried in the minds of pilots who had survived years of combat. For the men flying these missions in late 1944 and early 1945, this technological reversal produced something more corrosive than fear. In any single engagement, it produced a creeping fatalism, a sense articulated in countless post-war recollections by former Luftwaffe airmen that the advantage of initiative, the ability to choose when and where to strike, had passed permanently to the other side, and that every takeoff now carried with it the assumption that the enemy already knew. This was compounded by the broader technological asymmetry that had opened up between the two air forces by this stage of the war. While German engineers had made real advances in areas like jet propulsion with the Messerschmitt Me 262 and had their own radar and radio direction finding technology for night fighting and early warning along their borders, the sheer industrial capacity of the American and British radar programs, driven by the radiation laboratories, rapid wartime development cycle, and the mass production capabilities of American industry, meant that systems like the SCR-584 could be deployed in numbers and density that German countermeasures simply could not match. German radar warning receivers designed to detect enemy radar emissions and give pilots a chance to evade tracking existed and saw real use, but the sheer density of overlapping American and British radar coverage across the liberated territories of Western Europe meant that evading one station's beam often meant flying directly into another's, and the automatic tracking capability of the SCR-584 meant that even brief exposure was often enough to establish a solid track that persisted through evasive maneuvering. There is also a quieter, less dramatic dimension to this story that deserves attention, because the SCR-584 did not only serve as a weapon of destruction, it also functioned as the backbone of increasingly sophisticated ground-controlled interception, allowing Allied fighter controllers to manage complex layered air defense over vast stretches of contested airspace with a level of coordination that had simply not existed earlier in the war, turning what had once been reactive, scattered defense into a proactive system that could anticipate German movements based on the patterns of past raids, weather conditions favorable to low-level attacks, and known airfield vulnerabilities, essentially allowing the defenders to think several steps ahead of an attacking force that believed itself to be moving in secrecy. This same radar technology, refined and matured through the demands of European air combat, would go on to play a critical role in defending southern England against the V-1 flying bomb camp Agen in the summer of 1944, where the SCR-584's precision tracking, combined with the M9 director and proximity-fused anti-aircraft shells, dramatically increased the interception rate of these fast, low-flying, pilotless weapons, demonstrating in a different but related context just how thoroughly the balance of aerial ambush had shifted toward those who possess superior tracking technology. For the historian looking back at this period, what makes the story of German pilots confronting the SCR-584 so compelling is not simply the technical specifications of a wartime radar set, impressive as they were, but the human dimension of watching an entire branch of military doctrine become obsolete within the span of a single year, watching men who had trained their whole careers around the value of concealment and surprise come to terms with a battlefield where an invisible, tireless, mechanically perfect eye now saw them before their own eyes could see the target, and where the outcome of an engagement was increasingly decided not by the skill of the pilot in the cockpit, but by an engineer's servo mechanism spinning quietly in a trailer parked in a muddy field, translating radio echoes into a firing solution faster than any human mind could calculate. It is worth remembering, too, that this technological edge did not emerge from nowhere. It was the product of an extraordinary, sustained collaborative effort between British and American scientists, beginning with the transfer of the cavity magnetron technology to the United States in 1940 as part of the broader scientific and technical cooperation between the two nations, and continuing through years of intensive laboratory work, field testing, and iterative refinement that turned early prototypes into a rugged, reliable, mass-producible system capable of standing up to the mud, cold, and chaos of a European battlefield, a reminder that the war in the air was being fought as much in laboratories and drafting rooms as it was in the cockpits of fighter aircraft. By the time Germany surrendered in May of 1945, the SCR-584 and the broader radar-directed air defense network it anchored had become such a fixture of Allied operations in the European theater that its absence in the earlier years of the war seems almost unimaginable in hindsight. Yet, for the German pilots who lived through the transition, who remembered flying low over Allied airfields in 1943 with genuine confidence that they could not be seen coming, and who then watched that confidence evaporate through 1944 as flak batteries seemed to develop an uncanny, almost supernatural sense of where they would be. The change was neither abstract nor gradual in feeling. It arrived as a series of individually terrifying realizations, each mission confirming what the last had suggested, that the skies over occupied Europe no longer belonged to whoever flew fastest or lowest or with the boldest nerve, but to whoever controlled the invisible architecture of detection stretched across the ground below, and that architecture by late 1944 belonged unmistakably to the Allies. The legacy of this shift extended far beyond the war's final months, shaping the post-war development of integrated air defense systems on both sides of the emerging Cold War divide As military planners in every major air force absorbed the lesson that raw pilot skill and aircraft performance, however impressive, could be rendered almost irrelevant by a sufficiently dense and sufficiently automated ground-based detection network, a lesson that would inform decades of subsequent investment in radar technology, electronic countermeasures, and the endless technological arms race between detection and evasion that continues to define aerial warfare to this day. In the end, the story of German pilots confronting the SCR-584 is not simply a story about a single radar set, however remarkable its engineering, but about the moment when the ancient advantage of surprise, the oldest trick in the history of warfare, was quietly and permanently eroded by mathematics, by microwaves, and by the tireless, unblinking attention of a machine that never grew tired, never lost concentration, and never needed to see an enemy with its own eyes to know exactly where he was going to be.